Dear friends, in the last class we have seen what is meant by nodal analysis, how to write current matrix and conductance matrix and the voltage matrix. Also we have seen voltage to current and current to voltage transformation. Today we are going to implement this nodal analysis and the voltage to current transformation also in the same circuit in order to find the solution for the particular problem. So see the circuit. In this circuit, we are going to find out the current which is flowing through the 2 ohm resistance. Okay. So now assume the current here flowing is here I1, and this, if you see this, the current is going like this. Here the splitted into two, I2 and I3. So I will consider this is the one node V1. Okay. The voltage of the particular node is V1. And similarly this I3 current is coming here and I5 is coming and I4 is divided, it is deviated from this point. So I am going to take, this is another one node that is called as V2. Okay. Then in this case also I6 is coming, it is going down I7 and I5. I5 is also 8 ohms. So we are going to be take it as this node as V3. Okay, so this is what we are going to do. So now in our nodal analysis we use here this voltage source is there and one resistance is there. So three nodes V1, V2, V3. It will be good, we have to write the matrix as current matrix is equal to conductance matrix into the voltage matrix. The conductance matrix is nothing but 1 by resistance matrix into the voltage matrix. Okay, so in this conductance matrix we should write G matrix can be, we have 3 nodes 1, 2, 3 and this is the reference node. Usually if we no need to consider the reference node, we have V1, V2, V3. Reference node voltage we assumed as 0. Therefore we have 3 cross 3 matrix. So we can write otherwise this way. I is nothing but I1, I2, I3. Okay, I1, I2, I3. That is equal to G matrix. G matrix I already told you we have 3 cross 3 matrix. G11, G12, G13, G21, G22, G23, G31, G32, G33. Into we have the voltage matrix V1, V2, V3. That means V1, V2, V3 are the voltage of the particular node. So now I need to find out what is mean by I1 and what is mean by I2 and what is mean by I3. That means current in the particular node 1, current in the particular node 2, current in the particular node 3. That is called as I1, I2, I3. Remaining conductance matrix we know V1, V2, V3. So now how to find out I1? Here already we have a voltage source. We already studied how to convert voltage to current source, voltage source to current source. For that what we have to do, I am making this voltage source, converting that into the current source, that is called as I1. So I1, and here the resistance is in series, right? So when we convert that into the current source, what we have to do, we have to be connect that is in the parallel connection with the current source. So the same value is 8 ohm resistance. Okay, 8 ohm resistance. Then we have V1 and we have the voltage of, then next is 4. This is, let me use another one color. So let me draw first fully, after that we can note down all the values. V1 and we have next resistance. So I am using this current source as such. I am not going to change. Since this is in the same format, we have to be used all are in the current source. So now we are using here the 5 ohm and we will be connected. So let me draw now all the values. Let me write all the values. So this current is called as I1. I1 current, how to write? I1 current is nothing but we have this particular node, we have resistance is 8. So we will have 100 minus 8. So 100 minus 8 is 12.5 amps. So the current is 12.5 amps. Then 8 ohm, it is in parallel, I connected. Then this is the 4 ohm, and we have this is 2 ohm, and this is 3 ohm, and this 10 ohm and 5. Okay, 5 ohm. So now this current is 8 amps. Current is 8 amps. Okay. So now I am going to represent the voltage. Here this all are common terminal. This current source, 8 ohm resistance, 4 ohm resistance, all are connected together. So I am taking this is V1. So this is V1 means this is also V1. Okay, since this all are common terminal, and this is V2 and this is V3. Okay, this is V1, V2 and V3. V1, V2 and V3. I hope you understand how I have used this voltage to current transformation, voltage source to current. And now if you see this, we have this. Now we are going to write the matrix, all the matrix. How to write the matrix? Current matrix is equal to conductance matrix into the voltage matrix. So now what is the first node? First V1, one current source is towards the node, So towards the node means positive. So current source is away from the node means negative, right? So now here one current is joining his V1. In this V2, 8 amps is coming to the node. So that is also positive. But in V3, 8 amps is away from the node. Therefore, minus 8 amps. Already I have explained this. So now I am going to write this current matrix. First node, I1 is coming. This is all are common. This is all are common terminal. So I1 is coming. So that is equal to 100 divided by 8, 12.5. Then I2. What about I2? I2 here, this is I will assumed as I2. Okay, I2. So here in this current is coming here in this particular node. But what I2 is nothing but the current. So current which are source which are connected in the second node. So in the second node only one current source is connected, but it is coming towards the node V2. So therefore I will write 8. Then in this V3, this is I3. I3 is what? This 8 ohm resistance with respect to this node, it is away from this. It is going away from the node. Therefore, I am going to write minus 8. I hope you understand how I have written. Here positive coming towards the node. Here 8 amps is coming towards node V2. That's why 12.5 and 8. Here V3 away from the node. Therefore, minus 8. That is equal to, I am going to write now G11. G11 means what? 1 by R. So, total conductance of the particular node. Total sum of the conductance in the conductance connected in the particular node, G11. Therefore, what all the resistance are connected? 8 ohm, 4 ohm and 2 ohm. So, I will write conductance 1 by 8 plus 1 by 4 plus 1 by 2. Okay. Then what is G12? G12 is nothing but conductance between first node and second node. Therefore, conductance is what? 2. Resistance is what? 2 ohm. So the conductance, as this is between the two nodes. So we have to write minus 1 by 2. Then first node G13 is nothing but first node and third node. First node and third node, there is no conductance. There is no common conductance. So I have to write 0. Similarly, G21. G21 means what? The same value of G12 will come here. That means G21 is nothing but the conductance which is connected between first node and second node and first node. So the resistance is 2 ohm. Therefore, conductance is 1 by 2. Right? The minus is as this is common. Then second node, what all the nodes are? What all the conductance are connected? 1 by 2 ohm, 1 by 3 ohm, 1 by 10 ohm. So we can write 1 by 2 plus 1 by 3 plus 1 by 10. Then we can write it is second G323. G23 means second node and third node, which conductance is connected, resistance is connected 10 ohm. So conductance we have to write minus 1 by 10. Then 3 1 means what? Conductance between first node and third node, there is no common conductance, so we can write here 0. Then second, what is G32? Conductance between third node and second node. Conductance with third and second node is 1 by 10. So we have, it's a common, therefore we have to write minus 1 by 10. Then conductance of the third node, G33 is nothing but what are the sum of the conductance in the particular third node. Therefore 1 by 10 plus 1 by 5. Therefore 1 by 10 plus 1 by 5 multiplied by V1, V2, V3. I hope you understand how to write the Kirchhoff nodal analysis. Okay, how we have converted to current source and how we have written the matrix. So in your case, delta is nothing but what? This is the value of delta, and we need to find out what is our ultimate aim. We have to find out the current which is flowing through the 2 ohm resistance. So what is the current flowing through the 2 ohm resistance? That is equal to I3. So current means what? Voltage divided by resistance. So in this I3 is current direction is like this. So which one is higher potential? V1 is higher potential than V2. So therefore I3 is nothing but V2 minus V3 divided by 2 ohm, the respective resistance V by R. So our aim is we have to find out delta. Then we have to find what is delta? Delta is nothing but determinant of 1 by 8 plus 1 by 4 plus 1 by 2, then minus 1 by 2, 0, then minus 1 by 2, 1 by 2 plus 1 by 3 plus 1 by 10, then minus 1 by 10, then third one 0, minus 1 by 10, and 1 by 10 plus 1 by 5. So this is the delta. So in this delta, I have already calculated the value of delta. So I am directly substituting those values. So you will get this value as 0.875, then minus 0.50, minus 0.5, then 0.93, minus 0.1, 0, minus 0.1, we will have 0.3. So the delta value, finally we will end up with the value of delta as 0.16. That value will be 0.16. Okay. Then we need to find out V2 and V3. So how to find out V3? V2 is nothing but delta 2 divided by delta. So I am going to find out what is delta 2. So the delta 2 is what? The delta second column has to replace with this current. Therefore, first column as such, what is the value? 0.875 minus 0.50. Second column I have to replace with this current value, that is 12.5, then 8 minus 8. Then third column you have to write the same values, minus 0.1, 0.3. So we will have the delta 2 I already calculated. So delta 2 is nothing but 3.27, right? So I have one small correction. I3 current means not V2, this is V1 minus V2. Okay, V1 higher potential minus lower potential V2 divided by the resistance. So I have calculated delta 2, and delta 1 is nothing but how to find out delta 1? Replace the first column of the delta with this current matrix. Therefore 12.5, 8 minus 8, and these two columns we have to write as a minus 0.5, 0.93, minus 0.1, 0, minus 0.1, 0.3. So this determinant value already we know calculate how to calculate the determinant value, and you can refer the previous videos. In the Kirchhoff current law I have explained it. So this delta 1 is 4.16. So from this we can find out I1 is nothing but delta 1 by delta, I2 is nothing, V1 is nothing but delta 1 by delta, and V2 is nothing but delta 2 by delta. What is delta 1 by delta? Delta 1 by delta is delta 1 4.16 divided by delta is 0.16, and V2 is 3.27 divided by 0.16. So those values are 4.16 divided by those values. We will have the values of delta 1 and V1, V2. So we can have V2 is nothing, V1 is nothing but 26 volt, and V2 is nothing but 19.75 volt. Okay, V1 we have calculated 26, V2 is calculated 19.75. Now we have to find out what is the value of I3. I3 current is flowing between between V1 and V2. That means first node and second node. The value is 2 ohms current. The current 2 ohms is there. So the current which is flowing through the 2 ohm is I3. I3 is nothing but what? V1 minus V2 divided by 2. So V1 is nothing but 26. V2 is nothing but 19.75 divided by 2 ohm. The 2 divided by 2 ohm. So we will get this value as I3 is equal to 3 amps. We will get the 3 amps. So now from this we can understand the current, how to convert this source transformation, how to use the source transformation, and how to do this nodal analysis directly without writing all derivations. Directly you can use this current matrix is equal to conductance matrix into the voltage matrix. From this we can directly calculate the current. I hope you understood how to do this source transformation and the nodal analysis. So those who have not subscribed this channel, kindly subscribe. Wish you all the best. Thank you.